This conference will now be recorded.
It's taking forever.
Yes.
Okay. Because it's a big file. It's I think it's 3 gigabytes. So if you have slow internet, it might take very long. So you should have good internet. Maybe if you can connect, if you're at the office, you can even try connecting physically with LAN. It might help that it download faster. But yeah, I know. I understand it's quite a big file. So did you
Indeed.
manage to download it fully?
No, I haven't. It kept on cancelling. It says network failed most of the time. So,
Which browser are you using?
Google Chrome.
Okay. No, Google Chrome should be good. Sorry about that. Yeah,
It's
maybe
fine.
also you can also try to download it if you, I don't know if you're like me, you stay awake at night. You can try to download it at night when traffic, data traffic is minimum. Usually at that time at night, you know, big files can download very quickly.
Yeah, I'll definitely attempt again tonight.
Yeah, it should work. Yeah.
Yeah.
Yeah. Super. Okay, welcome, everyone. Just a quick introduction. My name is Treasure for the new participants, and I will be your presenter today on the topic of virtual MPS station, modular production system, using it together with Codesys version 3.5. For those that attended the previous one where we did the same with Tier Portal, this will be, well, not new to you, and we should be able to do more things today. So yes, my name is Treasure, and I'm employed at Festo as a technician. I've been with Festo for about 4 years now, and would like for well, we have Faith with my colleagues. We have also Mr. Vaynat, my manager, who's joined today, and we have also Adolf Huster, so, and 3 more participants: Tebogo Shabangu, our intern, and Tabelo from NMU, Nicholas from UJ. Welcome everyone. So I'm gonna get started right away because I'm trying to capture as much, utilize time efficiently. Now, I've asked you to download Cyrus, Codesys, EZOPC, and some packages for Codesys. So you can either use the chat function or you can talk. So if you can just give me feedback on your side, if you were able to download those applications and were able to do anything at all. Okay. So I take that you were unable to do anything at all.
Treasure,
Maybe
I
if you
don't
can.
have the applications loaded. I'll just be watching.
Okay. Okay, thank you.
Treasure is ongoing. I'm sorry I didn't manage to download. I was also not in the previous call.
All right, Faith. Anybody else?
It should happen quickly. I believe I have a good speed internet.
Okay. Does
Treasure,
any
are the links to the previous? Did you send an email in reply to the previous Cyros session with the links to download?
It was the invitation to this one, to this this session,
Okay.
where I've included the links. Yes.
Okay, very good. I'll quickly find them and I'll download.
Thank you. Does any one of you have Cyrus or Codesys at all? If you have Codesys or Cyrus in your computer, Codesys version 3.5, you can just say yes in the chat, or you can tell us if you do. Okay, just to look at an overview of what this is about. Now, as you all know that COVID-19 is forcing most of us to work from home, especially those in education. Well, it's affecting everyone, and it's affecting largely those in education sector, because you can't really do any practicals. And I heard that schools are reopening now, and so it will most probably be that colleges and universities will also open at some point. So this solution, what I'm going to present today, is something that is useful, that can help you, because you don't need to have physical hardware to work on this, to do this. It requires zero hardware. The only hardware you need basically is your computer, and that's about it. So this will be something that you can install on your computer, and students can also install on their computers. Now, the license is also now a question. How do we now go about with the license? So I know you, Jay, do have a license to Cyrus. So Nicholas, for example, what you could do is you can connect CodeMeter, the dongle, to your computer, and set up a VPN, virtual private network, so that you can have your students being able to open Cyrus remotely from home. And you can then give them exercises to write PLC programs. They can then send them to you. You then assess their programs to see how well they are functioning. So this is something that is possible with this solution. Another thing is, for instance, you want to already introduce PLC programming of factory automation machinery, such as the MPS stations, to the students that have no experience, for example, and you don't want them to work on the real hardware. What do you then do? They could write simulation, they could use Codesys visualization to do some basic simulations, but it's still, it won't go to that level of intensity, or that level of a standard. So now Cyrus gives you the opportunity rather the students an opportunity to program the stations, so that they can also not only program but also run and test it with a simulation which will be in Cyrus. This way, there won't be any damage to the real machinery. There won't be any risk of damage to the real machine. Now, what also happens in education institutions is that students would work on the station and they would fiddle and change IOs and change things, and eventually what happens is the station isn't working anymore because nobody knows how to rewire it back to the default where how it was. Cyrus becomes a good solution for that, because before they go to the real machine, they would already know how to identify the different IOs, how to write a program, how to work with the station, that when they get to the real station, they don't have to scratch their heads and try things that could lead to tampering with the station. Okay, so those applications which I've listed are all that we're going to need for this activity. Cyrus is number one. So Cyrus is a simulation software where we will have the MPS station, virtual MPS station. Codesys is a programming software which we use as Festo for Festo PLCs. To program Festo PLCs, we use Codesys, excuse me. So the new generation of Codesys, new version 3.5 is what we're going to use. Codesys 2.3, the older version, is also compatible. So you could also opt to use 2.3 instead of 3.5. It's your choice. So thirdly, we're going to need EZOPC. So EZOPC is an application which allows the OPC communication to happen between the two applications, which is Cyrus and Codesys. And thirdly are the target supports for Festo PLC in Codesys, which we're going to use so that we run on simulation. We simulate a Festo PLC in Codesys with an MPS station. Okay, if there's questions before I start, please do ask, or you can also write in the chat. I'm keeping an eye on the chat so that we can address your questions. Now, there's two Ciros versions or Ciros applications, the Ciros Studio and the Ciros Education. The two applications are different. Depending on what you're trying to achieve in the end of the day, you will use the different application. The Ciros Education application is okay. I just have to mute one participant here. Okay. Nicholas, I think your mic was unmuted. I've muted it. I don't know if you were trying to say something. If you were, please write it, or you can unmute and say something there for us. Okay. So Cyrus Education, it's kind of like you can think of it as light version of Cyrus Studio. Cyrus Studio is the full version. It has full features. And those features are such as saving a project, designing something, designing an application, or designing a system which you will program or which you will simulate in Cyrus. It allows you also to edit already existing models in Cyrus which have programs within them to make modifications to those models. While education, you cannot modify the models. It's a good thing because it really helps you as an instructor to sort of have a standard. You know, you don't want a student to design their own MPS. For example, let's say your topic today is PLC programming, and a situation, for instance, if you were to use Cyro Studio for that, it could lead to students modifying the MPS station, affecting the IO allocation, thereby making your job of marking or assessing the work difficult, because each one of them would have a different configuration. While if you're using education, the model are standards, so you don't have to try to figure out the IO allocations for each learner because they're standardized that way. So Cyrus Education is highly recommended for that. But I will use Cyrus Studio because I have saved the work that I'm going to present to you today. And also what I must mention is Cyrus. So if, for example, students are writing different PLC programs, either using Codesys or Tier Portal, so you will be able to take those PLC programs and run them and open Cyrus Education, open the model that's relevant to that PLC application, and then it will run. You don't need to copy a project, Cyrus project from the student and into your PC. You only need the PLC program to evaluate. So that's the thing about Cyrus Education. Now, so yeah, we're gonna start with Codesys. Let's start with Codesys here. So Codesys, for those that may not be too familiar with it, Codesys is an open source programming, PLC programming software that supports different brands of PLCs. Of course, number one being Festo, and so you're able to program different Festo PLCs such as the CECCLK, the CPX. You're also able to program the CDPX, which is our HMI that is integrated with some IOs. Although not the visualization part, only the logic part in terms of the PLC program. You're also able to, configure valves, our IO-Link valves, our can open. You're able to do such communication, field bus communication of different devices. So this is basically the project startup here. So I'll just write here today's date, 21st, I believe. So now here you need to select CECC project. By the way, this will not be visible until you've installed the packages in Codesys. So please do that first, install the packages, and then start the project. Yes, Nicholas, you're quite correct. You need to register before you download Codesys. It's free, so it's not like they're going to need your credit card details or any payments. You need to create an account because this is important for the software developers to know who is using the application. So you just need to provide them with your details, such as your email address, your what the type of industry which you're going to be using Codesys for, and from there they will send you a link to approve, because just to make sure that you have entered correct email address, and then from there you should be able to download Codesys Codesys Service Pack 15. We're going to add iLink Master because with Cyrus, with the MPS station which you're going to use, it has 2 bytes of outputs and 2 bytes of inputs. With just the onboard IOs, we only have 1 byte of output. So the reason behind selecting iLink Master is so that we can have an additional byte, so that we can be able to have monitor and control the inputs and outputs of the station. I will select structured text here. So I hope that this is not an issue for everyone. Now, I would like to encourage, if you do have Codesys already installed and the target support installed, I would strongly recommend that you follow what I'm doing here, because the purpose of this webinar is not only for me to show you how to do this, but it's also for you to do it on your own, and we have a look at what you're doing to help you, basically, so that after this call you don't try to think, what did he do at that step? Because when you're doing it as I'm doing it, it becomes, you will remember it easier. Writing notes is one thing, but doing it physically, it will help you big time to be confident enough also in the future when you're going to have to do this on your own or with your learners. Okay, so I have the iLink master here, so I will come here and plug device. This is that BNI IOL device, BNI IOL that you have to download or still going to download. So this is it here. I'll select the most recent version, which is 1.4, and I will plug it. All right, so this is what it basically Codesys looks like for those that are new to Codesys. This is the PLC itself, project tree here. This is the PLC itself, and under application, this is where we have the PLC program. Well, some of you may think of this. You can think of this as a block. This is where I write my code, and this is my onboard IOs in terms of the digital inputs and outputs on the PLC itself. And these are the remote IO link devices that I can plug there. What is important is that we need to select here enable to. This is so that when we are logged in online, we can see the state of the different IOs of the different all the inputs. We can see the state, whether it's false or true. because otherwise by default it won't update unless such variable is used in the program. So we need to do the same thing with the outputs. Also under the remote IOs, we need to do the same thing. Enable to. Now, the next step is also very important. You need to add symbol configuration. Usually after adding symbol configuration, it requires you to build. Now, this is very, very important. You need to tick both of these here, constant and IO config globals. And also you need to go to settings and enable direct IO access. This is so that Cyrus can access the onboard IOs of the PLC and also basically all the physical IOs. Okay, maybe I shouldn't use the word physical. Let us say all the IOs in the project with addresses. Okay, so I'm just gonna leave it like this for now because I want to make sure that my communication is 100% before I start writing the program. At this point, I will start Cyrus Studio. So this is what you must also note, actually, is that OPC, it is part of Cyrus. After installing it, you don't actually need to do any settings, except for one, and this is one time. You need to set up here, Codesys settings, you need to select which version of Codesys you're using. Once you've done this, you don't need to come back every time and change it. And what's also important is you need to come here as well to select which applications you need to have communication between. You know, usually people don't use step 7 and Codesys simultaneously. In my case, I do because I have to show you the different ways. But for you, if you're using Codesys, you just select Cyrus here and then you select Codesys, and then you don't need to change this every time. You just leave it like this and then you're done. But for those that are using Siemens, of course, you need to select Siemens, and then also you don't need to come back and change it every time. And then once you've done this, you can minimize or you can close, and that's about it. And you don't need to open either OPC again unless you want to check something, because Cyrus will automatically open it once you start simulating. So this is model library. This is where you select which models you want to have in your project. So sometimes it's not shown. So if it's not showing, you go to models and you can go to model libraries, and then it pops up. And now these are all the different things that you can add into your project. For the purposes of today's webinar, we're going to add the basic MPS station, which is the distribution conveyor. Okay, this is the distributing conveyor, and this is my work table where I will select the different materials to load into the magazine. All right, and now we need to go to a model explorer, and we need to go to objects. We need to go to distributing conveyor, the station, and PLC distributing. We need to go to properties of the PLC, and we're going to change this to OPC client. When you do that, this will then pop up under general. You need to go here, localhost, and here you need to select Festo EZOPC2, what is showing. Sometimes it's not showing anything. If there's nothing there, you need to refresh and you will have all the different things to select. Now, if EZOPC is not installed, there will obviously not be, it will not be an option here, which means that you will not have communication to Codesys from Cyrus. So you need to install EZOPC, only then these options will be visible. Now, it's important that you select the correct EZOPC here, which is 2. And from there, you need to open here, go to items, and then you need to connect. You will see immediately when I click on connect, EZOPC will pop up and apply. And that's it. Luckily for you, that's all you need to do pretty much in Cyrus in terms of configuration. So let's run. In Codesys, what you must do also, you must turn on simulation. Once you've turned on simulation, you can then log in. Because as I said, we're not using any hardware. So by turning on simulation, it simply means that we are using the internal PLC controller of Codesys so that the project is loaded there instead. And then from here, you can run the project. So it's running. Let us see here. Now, if this was communicating, already there are some inputs that are on the station. So I can tell immediately that there's an issue somewhere because none of the inputs is actually on. So I need to figure out why this is. So we're going to open EZOPC. So it does show that Codesys is connected and we have one client. In this case, this is Cyrus. So I'll go to Codesys and you can see that there's nothing. Visual controller, there's nothing. All right. I'm going to try to turn on an output to see if it will get to the station. Let's see. There is communication because you see that as soon as I turn output number 4, ejector came out, it extended. Let us check inputs again. Okay, there is something here, something has turned on. All right, perfect. Okay, now this is where it gets interesting because if we're going to write a PLC program, we need to declare our variables. We need to know what sensors we have. We need to give them titles so that when we write our program, we don't refer to addresses in our program. This is a very important thing to do. Now for outputs, it's very simple because you just turn on one by one and see which is responding. So in this case, I've seen that as soon as I turned on output number 5, the ejector came out. So I'm gonna make it false here. So we're gonna, what have I done? This is inputs. Okay. We need to go to outputs and we need to make this false. So this is output number 4. So you can log out and give it a title and log in and give it a title, one by one. I prefer to use Notepad for this because, I don't have to log in and log out too many times. So I'm just gonna come here and I'm gonna say, we have outputs on the control panel and also we have outputs on the station. So it's important to distinguish the difference. The first which I've identified is the ejector. So you can use term ejector or you can, standardize and use the similar terms which are used in Cyrus in terms of the labels, which are also printed on the physical outputs themselves, which is something I recommend because this is going to be very helpful if you're going to be doing any troubleshooting in the future. And also, these are the same terminologies that are used in the circuit diagram of the station. So, you can see immediately why I'm saying what I'm saying. So you can see those labels that I'm talking about. So these G1, BG1. So this is something I recommend for you to use. But in this case, our outputs are not given labels, are not physical in Cyros. So if you want to get those labels, the student would need to refer to the circuit diagram. But to not make my story too long, I will skip that, and I'm going to use I'm going to say M1, for instance, for the ejector. Okay. Let's see what other outputs can we find. So 0 is actually a conveyor, but we can't see anything because we don't have any material on the station itself. So I'm going to load a workpiece, eject it so that we can see what if indeed output number 0 is the conveyor. So you can see that conveyor runs forward when I turn on output number 0. So I will write it here. So I'll use K to refer to motor and M to refer to valves or solenoids. Okay, so we've seen conveyor running forward. I'm going to turn it off, turn on output number 1, turn it off. There's nothing there that we can see. So let's turn this on. Output number 2 is the gate. So this is the gate here. Now this gate is basically to block any materials that are coming. For example, you don't want to eject a workpiece while there's a queuing of workpieces on the conveyor. You want to make sure that the conveyor is clear before you can put a part on it. So this gate here is basically to block any other material that are coming from downstream stations, which would be here. In this case, we don't really have those, so it's not really an issue. We can even not need to include it in our program because it will not have any effect, but I'm going to declare it anyway. So that is output number 2. Looks like I forgot X here. Stopper. Okay, so for the inputs, like I've mentioned in the previous session, it's very tricky to identify inputs with the station because it's not like with a rail station where you can go physically and place the workpiece and have it stop there and observe which sensor is turning on. So for that, this is the reason why, if you look here, they're shown to the students the labels, what each input is. But for the outputs, it's not shown because this is part of them learning to how to identify the different variables. So inputs are here. So I'm just gonna type them in here quickly. And we have G1B, I'm going to turn on capital letter G1, BG1, which in this case would be at address 0. So the first input here would be address 0, address 1, 2, 3, 4, 5, 6, and 7. All right, so this will be at percentage, this will be IX 0.0, and this is a Boolean. And so this is a comment. Let's say beginning. So we also have G1, BG2, which is workpiece at middle. We have G1, BG3. G1, BG3. And we also have 2B1. Now this has no comment, it just says PLC input. We will just write it as it is. So 2B1 is an optical sensor. So I'm not so sure which this one is, because in our case, we don't, all the optical sensors are declared here. So it could be that this is probably most likely to be an unused variable. But I'm gonna include it anyways. Also to note, with PLC programming, even with Siemens portal, it's important that you don't write your variables starting with a number. If you have a number, you should start with an underscore. In fact, I usually make it a practice that for every variable, I start with underscore. This is just to prevent any problems. And they call this one a PLC input. We also have, so this is on the magazine module. So these are on the conveyor. And now we come to variables which are located on the magazine module. And we have C1. So now they're no longer G, it's C1. C1, BG1. So this would be, they say it's a slide what? Slide retracted. So we have slide extended as well, which is going to be the second. So we have C, what have I done? We have C1 and BG2. Tab, paste, and this is slide extended. We have magazine empty also, which is going to be C1 BG3. There we are. So I'm going to stop here in terms of declaring the variables. We will look at the panel later on. Okay, so let me just make sure here. So this needs to be 5 and this needs to be 6. Number 7, I'm going to skip it because it's also a reserved variable. That's about it. So I can take these now, and now I can log out. And I can put them here. And so I have conveyor belt. Yes, now I can start writing the PLC program. So I'm gonna just have an internal flag that I'm gonna use to start the system. So that I can have a start. Now, I hope that you might be familiar with this type of programming. Codesys structured text. It's not exactly the same as the Siemens structured text. There are some differences, minor differences. So, but if you are not understanding something, I'll be more than happy to explain to you. So we're gonna use steps. This is just to make sure that we don't have clashing signals or interlogging signals. Now, also, this is the thing that I must mention. Start in this case is a flag which I will simulate on off, but in real life it's a momentary switch, this thing, which is on for a short period of time. Now, to avoid a situation of a uncontrolled or unstoppable continuous cycling of the steps, we need to use a trigger so that the start will become a momentary, resemble a real momentary switch. So that we can use the output of the trigger to start our program. So if the output of the trigger, which will obviously be the start button, we then want to eject a workpiece. Obviously, we also want to make sure that the magazine is not empty, because we don't want to start the program if magazine is empty. So this will then be, so in this case, we must note that this here, we can use address, or we can use that. So I'm going to use this instead, the label. So G1BG3 would be magazine empty. Of course, we need to say not, because when it's a 1, it's to indicate that the magazine is not empty. And when it's a 0, it to indicate that, actually when it's a 1, it indicates that the magazine is empty. So we don't want magazine empty. And then we can then say here, we can eject the workpiece. So now that the magazine cylinder has extended, we need to check, this is the feedback, very important, to check that the cylinder has fully extended. We will then use the variable which is associated with the proximity switch at extended, which will then be slide extended, which is G1 BG2, so C1, excuse me, BG2, cylinder extended. We need to then run conveyor. We need to then run conveyor forward, which in this case we've called it K1. And we must not forget to reset the previous. So that we have the cylinder retracting at this point and conveyor running forward. So now we have conveyor running forward and magazine retracting. Okay, and we must also jump to step 20 here. Next step. So in this case, now we have conveyor belt running forward, and we have magazine cylinder is retracted. So workpiece will at some point reach end of the conveyor, which is this sensor here, workpiece at end of conveyor, G1 BG3. But also we must note that if we stop conveyor immediately when this sensor picks this workpiece up, conveyor will stop and workpiece will remain on the conveyor. We want the workpiece to fall off of a conveyor. So we need to delay. We need to delay the off state of the conveyor belt. And to delay, you will see that I'm not putting my function blocks, I'm not calling function blocks inside the steps, because when you call function blocks inside the steps, it becomes invalid, or rather unoperational when PLC program is executing a different step. So it's very important that you call function blocks outside of the case step of. So I'm going to start the on delay as soon as we jump to step 20. And then I'll then use the output of this timer together with the sensor so that we stop the conveyor. Let me make it 4 seconds. It might take longer. So that I can say that if the output of T on, to verify that indeed the workpiece has had enough time to fall off of a conveyor, together with the sensor itself, so that we say that not, because to make sure that we don't turn off the conveyor while the workpiece is at the end of the conveyor. So we'll say not workpiece at the end of conveyor. This will then be a good moment to stop the conveyor. The program is complete. I hope that we won't have any errors here. I didn't move these things. This should not be here. Then yes. If then okay. Perfect. Okay, so we will then test this small brief program. So I need to load a workpiece into the magazine. Okay, there we are. So this is what I meant. You can see that it takes me a while to change state of a variable. By the time I change start to false, the process has already completed. And if I don't use a trigger, this will become continuous and I can't stop it until I make this false. So trigger helps me to be able to simulate a momentary on-off. And another workpiece will be taken out only after I trigger again the process. It won't start a new process for a reason, and this is because it's stuck at step 20, so I need to forget to write here that it should jump to step 10 after this. Actually 0. Oh, here we are. Is there any, let me just check under chats. I haven't checked chats in a while now. Well, there's still no new chats. Now, now I can continue to declare the variables on the control panel. But I would just like to get a response from you so far. Is everybody good? Is everybody happy? Everything is well explained?
Yes, thanks, Treasure. I still haven't managed to download the software. It's probably because I'm streaming the webinar at the same time. The download is taking forever. But yeah, thanks. It's looking good. It's also good to see Codesys programming. I haven't done that yet.
Thank you. Let me continue then. So this, I will send you this project after the webinar, and then you can, if you maybe want to check something, you can check so that you're not completely in the dark. As I said, you don't need to do any changes in Ciros, you just open this model, which is the distribution station, and then you just go to OPC, you add EZOPC2, and then run simulation, and that's it. So this is really a positive thing. Now, as with the control panel, this is basically here. This is these shortcuts here to monitor IOs of the station itself. So when I click on it, you will see that this menu pops up, and this is basically to show me the state of the different variables that are on the station. And you will see when I scroll down, you will see the distribution panel. This is S1, S1, S2, S3, S4. These are switches or push buttons that are on the panel. And we have emergency, emergency, let's see if this panel has it. It doesn't have it, but some panels do have it. And we have communication. This is when communicating with other stations. And then we also have panel outputs, which are shown by P1, P2, P3, P4. These are the illumination of the buttons on the panel. So we have start. P1 is to illuminate the start. P2 is to illuminate the reset, while P3 and P4 are Q1 and Q2 indicators, which are these over here, Q1 and Q2. And then we have Q4, Q5, Q6. These are for communication with other stations so that you can connect via lab cables to downstream and upstream stations. All right, so we will go back to Codesys now to declare these things. So I'm going to log out. Let's say outputs, start with the outputs, because we started with outputs with the station. And here we have P1 is the first one. So also here, we need to know the address. So before I start writing addresses there, let us verify the addresses of these variables. So I need to go to Model Explorer and PLC properties. Okay, so you can see here S1 is byte 1, bit 0, and so on. So this is using byte 1. Let us confirm also the outputs. So outputs are also using byte number 1. This is good. There's just only one problem, unfortunately, which I will explain to you in a moment. So now the PLC which we are using comes with 2 bytes of inputs. Now the second byte is incomplete because physically on the PLC itself, we have 1 byte, which is this, of course, with 0 to 7, and we also have byte number 1 with only 6 inputs. Now this is normal because PLCs, usually have more inputs than outputs, because it's usual that you have a system. Usually systems have more inputs than outputs, and I think it's something. It's a good thing. It's a good thing because you want to listen more than you speak, actually, so that you gather more information before you can make decisions. Now, this is not good for us because of the fact that we could be having bit 6, bit 7, which we don't have here, right? But for the control panel that we're using, luckily input 6 and 7 for this activity we're doing now, we won't need to use them. However, should you find yourself needing to use 6 and 7, then let us see if you have them here.
There's also
Then
another
what
reason
I
for having more
recommend,
outputs than inputs, Treasure. Outputs are expensive, inputs are cheap, simply due to the electronics involved. An input is simply a transistor looking for a voltage, whereas an output often needs to drive power, and the power electronics behind it are a lot more expensive than the inputs. So that's why PLCs usually have less outputs than inputs, and why you need to use expansion boards.
thank you. I didn't know that. So one simple solution for you I can give you is to change the byte of the inputs of the control panel here. So you can change these to byte 2, because with byte 2 we have complete bits. We have complete bits of from 0 to 7. So you can do that by going here and coming to bits and just dragging byte 1, bit 1, for example. So you just drag byte 1, byte 2, excuse me, byte 2 and bit 0, dragging it and paste or and dropping it over there. So you can do that. But I think I've emphasized enough on that. Let us continue with this declaring of the inputs. So P1 would then be the start illumination, which will be at address %QX 1.0. This is the first output on byte number 1, and this is of course a boolean or a bit, and this is a start button illuminator or illumination. Let me say illumination. We have P1, P2, P3, P4, and so on. P4. So we know that this is a, I'm gonna change this to 1, 2, 3, and we have start button illuminator. This is a reset button illuminator here, and then we have Q1 and Q2. Now we come to the inputs. So all inputs are labeled S1, S2, S3, S4. Because we don't have emergency button on our station, so we will leave that out. So we'll only do S1 up to S4 here. S1, it's IX 1.0. So this is the start button. This is stop button, this is reset button, this is automatic manual. So start, stop, and then we have reset. I'm not sure which comes first, whether it's reset. Oh, yes, it's reset. Reset, and then this is a switch here. This is automatic manual switch. There we are. Now you will see that we've come, although our program runs, there are some situations. For example, it could be that I stop simulation while the cylinder is extended, and when I start to run the PLC program, the system is not in initial position. What happens? My program will not work. It will just freeze. I'll have to stop it and disconnect air, or rather do the manual override on the valve so that I can retract the cylinder. This is obviously not something possible with a simulation. Here, the only thing I can do is just to stop and then start again. Everything will start in initial position. That is the difference between visual and real system. But what is important is to program, to include this in our program so that we can reset the system. Imagine that you have a plant of 100 square meter. You know, you're not going to go to individual valves and do manual override to reset them to initial position. Your program needs to do that. So that is something that you will obviously, of course, have to program. And so you want to stop the program that it doesn't, if there's an error or there's an emergency, mild situation, then you need to stop the system. Or if you want to do some modification, whatever, you need to stop the system. And automatic manual basically is a key, which is important. So this is the key which you can detach from the station so that there's no unauthorized operation of the system. And so unfortunately, virtually, I cannot disconnect the key, so it's always there, but we will, pretend to a role play that that it's possible to remove the key. And where would we put that information in our program? So that will be here, so that we would then say end. So when S4 is high, it simply means that the system is on manual. And when S1 is 0, it simply means that the system is actually vice versa. When it's 1, it's auto. When it's 0, it's manual. So end S4. This will ensure that this process will not start unless the key is present. So just adding S4 there. And so for start, what I will do is I will just change it here so that I don't have word start. I instead use S1. And then I can change here, take this out because I don't need it anymore. And then I use S1 for this purpose. And then for stop, so let us see, stop. Stop is, there's many ways to deal with stop. Now, the easiest and quickest that I can demonstrate now is this one. So I could say, because remember, stop is normally closed. So we need to then have if not, this is S2, right? Yes, if not S2, then we need to jump to step 0. Just like this. Now we come to the last one, which is the reset button. Luckily, this station that we are using does not have any memory valves, which simply means that immediately when there's air on the station, virtually, the station will by default go to initial position. But what is important is in our reset step is we need to make all the outputs which were true previously to make them false so that everything will turn off. So also actually with let's see. So when you press stop, it needs to the conveyor belt must stop running, isn't it? So that you don't have moving parts, and that is the only moving part which we need to stop for the stop. So I must just include K1 here. That K1 should then be false. And now we need to also do the same kind of thing for the reset, so that we say because the reason why in the stop we only make we stop the conveyor and we don't stop the ejector, because when you press stop you want everything to stop. Imagine that the magazine, the cylinder on the magazine is fully extended and you press stop. You don't want it to retract because it could be that you are seeing a potential danger if it retracts, so it must stop while it's extended. While the conveyor, you know, if you stop it, it won't move. So, and if you don't turn it off, it will continue to run. So that's why we do it there. Now under reset, we need everything to go to initial position, which means making all of the outputs false and any internal flags really to be false, because we want to initialize everything, and also the step to jump to 0. So here we'll then say if this is S3, S3, then step 0. The reason why it has to go to step 0 also is because if you don't go to step 0, what's going to happen is that there will be a conflict in terms of the signals. It could be that you're not resetting it to step 0 and the program is at step 10, for instance, and at step 10 you're making K1 true, and here you're making it false. Then you have that conflicting signals, conflicting commands rather, and this is not something that we want. So K1 will then be false. Also we need before I do the function blocks, I must finish with the outputs. So this is M1 and M2. K1 or K2. K2 also to be false. Now we must also make the function blocks false. Which we have only one of them in this case. Now also it is important that the operator knows the state of the station by looking at the control panel, because control panel in this case is really the only communication, or not only, but main communication between the operator and the machine. So what we call HMI. So now the illumination that we have declared, we need to also include them here, and you will see that we would like, so now you can you can do it how you like. For example, you can flash the start button, you can make it solid when the system is running. You can do it how you like. However, there needs to be a standard. Now usually, of course, start we illuminate it to indicate that you may press it. I mean, we flash it to indicate that you may press it, and once you've pressed it, you know, it turns solid. And same thing with reset. You know, we flash it, and we make it true once you've pressed it. This is that, you know, the communication. Q1 and Q2 are really flexible. You know, you can use them for anything, but usually, or for this station, it's very wise to use Q1, for example, to be solid when so to be solid when the error, this Q1, Q2 can be used for error purposes, so they can remain off if everything is good, so that we flash it if magazine is empty, for example, or also we can flash Q2 if stop button is pressed, something like that. You know, you can define it how you like, Q1 and Q2. So let us do it like I've just explained. So now we will start with the start Eliminator. So with start Eliminator, we need to flash it, isn't it? We need to flash it in step 0. It needs to flash in step 0 when everything has reset. Okay. And how do we know that everything is reset? We must look at all the inputs, so that if all the inputs that that defines initial position are all there or all true, then this should then indicate that the system can be started. And those inputs we've declared them, and here they are. So for example, none of this must be on, because we don't want to start the system if there's already a material on the station, on the conveyor belt. The conveyor belt must be cleared of all the things, so that when we start the cycle, there's no some confusion in terms of the execution of the project. So these must all be false, and magazine must not be empty, because if magazine is empty, you can't start anything. Also, the slide must be retracted. This is to verify that the system is in initial position. So we must list all of those here. And of course, this is going to be workpiece. If this is going to be not, and also not workpiece in the middle, and we also so this must not be a not, because this is true when there is no workpiece, and it's false when there is a workpiece. So we must leave out a not for this one. And not magazine empty also, and not cylinder retracted, and cylinder retracted, and magazine not empty. So not. Just like this, we can then start flashing the Eliminator. Now, for flashing features, you need to install or include or add a library we call UTIL, utility library. This will make the advanced function blocks available. We're going to call it flash start. So that I can come here and then say then. So that I can come here and say then, once all of these are true, I need to equate the P1, which is the start Eliminator, to the output of the blink or the flash. But also I need to define the duration of a high, the duration of a low. I also need to define what starts this this function block, and I also need to call the function block. So I'm going to call it here. So that it's enabled by we enable the function block here. We enable function block. We also equate the output of the function block to the output, but also I'm going to define the duration of a high and the duration of a low here. Which so because of the simulation, there is a we call it a frame. It's not frame rate, but something along those lines. The refresh rate. Refresh rate. There's a delay in terms of the refresh rate. So if you're gonna make small values in terms of the high and the low of a flashing, it might have a negative consequence. You know, you might not see it accurately. So I'd suggest that you don't make it too low. You know, things like anything below 0.5 is not going to work for you. So maybe 0.9, 1 second, almost 1 second. So let's just make it 1 second. Yeah, 1 second is perfect for this. So 1 second high, 1 second low. So now we need to define 1 second low. There we are. So that when we start the system, the start button will flash. And after this, we need to make it not flash anymore. So when you press the start button, then system then goes to step 10, and in step 10, this is when we might want to disable the function block of flashing. And also because we want it to be solid when the system is running, the start eliminator I'm talking about, so we can then say P1 here, we can then make it true here. So this will make the start eliminator flash when the system is in initial position, it's ready to start. We press the start button, and then the start eliminator will then become solid on. So let us test this. And I think I will stop here, because if I have to include every other illuminator, then the program is going to be so big, and I can imagine for you that are not the authors that it's probably already starting to become convoluted, and you might be getting lost, and I don't want to make you lost even more. So I'm going to stop at this point and not expand on the program any further. Okay, so now here we have, this is good, this is false, false, and G1 BG1 is false. What is this thing here? This is conveyor workpiece at beginning of conveyor. So I should have written not, because workpiece at beginning of conveyor, it's also a light barrier, which, let me confirm what I'm saying first. No, it's not. So if it's false, then I don't know why, but I'm gonna just change it here to a not, because it looks like it is wired somehow. So I'm gonna change this to a not. So the start button is now flashing. So I'm gonna load a workpiece, and then we will see if it becomes solid. There we are. So it hasn't started for some reason. Let us see what's going on. So we're still in step 0. If not, yes, and GB1 and not, this is perfect. And also we come to, oh, okay. Trigger, so this is the output of the trigger, and the trigger is linked with S1, which is the start. So we're using the trigger output. Let's see. S1. I'm going to get rid of the trigger because now that I have the ability to press it momentarily, then I can omit the trigger. Yeah, we still stuck at step 1. So start turns true and S4. S4, we said that S4 is automatic manual. So I need to turn it to automatic first. So it is now in automatic, but still S4 is not true. So can you see that? Can you see that? So S4, which is the switch, needs to be changing the state, but it's not. Instead, S3 is changing state. So which simply means that my addressing was incorrect. So let us press reset and see. Reset responds to automatic manual. So I need to update this here because I didn't address it correctly. S3 and S4 are vice versa. No, I just need to change here. So this becomes 3 and this becomes 2. Yes, just like that. Let's see if this will get it to work. So indeed, now this is good. So if now the start illuminator is on, it's flashing, now press it, it becomes true. There we are. Okay, that's about it. I don't want to go further with the program. As I said, I will stop at this point, and it's a good timing also because now we have 34 minutes remaining. Now I would like to engage with you further about this. Some of you were busy downloading as I was presenting here. If you were able to install and do something on your own, or if you were writing this program as I was doing it, tell us if you're having any errors, and let's see how far we can get you to get to this point. Yeah, so and also just a feedback from you. How did you find this this tutorial, if I may call it, and how do you find the solution altogether? Do you think that this is a good solution in terms of simulating programming hardware in a simulated environment, or do you think this can be a suitable solution for you? The floor is yours. Mr. Maseko, how are you doing?
I'm good, and how are you, sir?
I'm also good, thank you. I received a request from Mr. Neka to join. He wanted to join this, but I don't know because I don't know what happened. I did send him an invitation, but he's not in to participate. I don't know for what the reason is. Because I believe that they have Cyrus at Vereniging campus. I'm not so sure if you do at Sebokeng. Do you have Cyrus at Sebokeng?
Not yet.
Not yet. All right.
Yeah.
So what do you think about this? What do you
It's
think
great.
about it?
No, it's great, and it's making life easier actually. As I was watching, I could see really it's making life easier.
Mm.
Yes,
Yeah, because
we'll have to source it soon.
Okay,
Yes.
that's great. Because also one thing that I must also tell you is that Codesys is open source, which means it's free of charge. You can install it on all those computers in your lab, all of them, and have the students writing PLC programs. I'm sure probably you're already doing this. And also, I just wanted to mention, I just remembered now that one college that I've been to has a lab for the station, the machines, which is separate from the computers. The computers are located somewhere else while the machines are located somewhere else. And students had to carry the PLCs with them to the computer lab, load PLC program, and then go to the lab and test their work. Now, this
Okay.
is becoming, this is a good solution for such a scenario, because what it simply means is that the students will program this virtual MPS station. Once they are 100% sure and have tested the PLC program, they can then go to load it on the real system to basically confirm that it will work on the real system. And what will usually, or what will most likely happen, is that if the station hasn't been tampered with, it will work. The program will work. But if the station has been tampered with, for example, the sensor has been disconnected, then the station will not work. And this will now lead to the next part of the practicals, I believe, which will then be troubleshooting. The student has tested the PLC program and they know 100% sure that the program is 100%, it works. Now it's a matter of getting the station to work accurately.
Okay.
Yeah.
That is not a problem with me. As soon as I find any station that is not working, I'll fix it.
All right. Great stuff. Thank you for your feedback. Nicholas, I remember last year, I think we, when you had problems with Cyrus, I came there and I even told you about the solution. You were quite excited and looking forward to the solution. So, you know, when you eventually go back to when you reopen to work, you know, do you foresee being able to use this thing and not having problems?
Definitely. I think I would be able to follow, especially if you can hook us up with these videos. I think I would make so much progress. My biggest challenge, you see, with these learn computers, and you're not the IT person, at times you find that these guys, the response rate is very poor because they create an image. For instance, right now I don't have Codesys in the computers, but I have Ciros. So now when we open, I would have to wait around about a month or so trying to push them to roll out Codesys as part of the image, because as soon as I add something, apparently they want to change the whole image of I think about 400 computers for different venues. So it becomes a bit of a problem when I want to edit things timelessly, but it's something that I'm looking forward to push, because I really need it. And with what you have just shown us, I believe I will make a lot of progress.
Okay, that's very good to hear. So if you need any support from us, let us know, and we will do our best to assist you there. Because I know what you're talking about. I mean, I've been to your lab. Your computers are networked, and yeah, it can be a bit of a nightmare to get things done like that, especially when you're relying on IT for the administrative powers that you don't have. Yeah. Okay,
Yeah,
cool.
and even the dongle is there with them on the switch. It's not with me. It sits there on the switch in their offices actually. So it's difficult,
Yeah,
honestly, to do things on my own. Yeah.
I think it's good actually that the license USB is on the server computer, because
Yeah.
this and I must also mention that do you have VPN? Are you using a work computer, or is it your personal computer?
On my case, I'm using a personal computer, but we were informed about VPN. The only thing was that it was being facilitated by a different team, because every department has their own IT guys who specializes with their lab specifically, and there is the university, what you call the campus IT guys. So those are different type of people, and these other ones they were already at home during this lockdown, and it wasn't gonna be easy for me to tell them to go to their offices and set it up for me. So the university was preparing it for the academics, but on the technical side, we we were not prepared enough to get to that point.
Okay. So what I will also want to mention to you is that if you can connect to, if you have internet, if you have modem at home, if you can manage to get VPN set up on your computer, that you can access work emails and anything work related on your computer, then you will be able to run Codesys in your laptop, and use the license which is located at work in the server. This is remote, because you have a network license. So
Yes,
I will show you how to do this. Once you have VPN on your computer, you must just note down the computer name, the server name, the name of the server or IP address of the server, and then that way, let me just demonstrate it to you quickly as I'm speaking, because this is something you can also do it on your own actually. So when you install Ciros or FleetSim, any of our software, licensed software, it uses CodeMeter to manage the license. Then you can you open it CodeMeter, you go to web admin and configuration, and then you go to server, and then here you see how simple this is. You go to add server, and then here you then type IP address of the server computer or the name of that computer, and then you add it. Just that, and then you will then be able to run Ciros on that license, on that network license.
Okay, then it will do the searching by itself, isn't it? Locating the license.
Yes. Even for same thing for FleetSim, hydraulics, FleetSim, pneumatics, same procedure. Yeah.
Okay, no, that's good. So now, if during this procedure, I will still need the VPN to be set up still, or I can just.
Yes, because VPN is going to allow your computer, because without VPN, what's going to happen is that when you punch in IP address in the in CodeMeter, and you're connected to like network in terms of whether it's Wi-Fi or let's say telecom, whatever, then it's going to look for devices in that network on internet with those IP addresses. And you can imagine that internet is, there's like thousands and probably millions of devices that are connected. So chances of it finding the correct one, like trying to find a needle in like a in a sand. You know what I mean? So you need so VPN is a virtual private network, which simply means that when CodeMeter looks for this license, it will search specifically in that private network, where private network will be UJ computers. So that minimizes the amount of devices. That way it will find the license quicker and more efficiently.
All right. No, it's not a problem. I'll try to inquire with my guys, Buma Shudu and Stan, and then I will take it from there.
Great. Best of luck. Okay. Yeah. So any other question or anything anybody would like to bring up before we end this session? Okay. So, well, good luck to you all. Wish you best of luck with this Cyrus and Codesys. And enjoy the rest of your day. Take care. Look after yourselves.
Thank you very much, Treasure. Enjoy your day.
Thanks, Mr. Masako.